Hey all, welcome back to the lab. In this video, we are going to be building a simple F# Lookaside cache. Alright, so what is a Lookaside cache? So a Lookaside cache is one of the most common types of caches. It's relatively simple to implement and reason about while potentially, if you use it correctly, offering substantial performance improvements. So is often a first choice when you need to add caching until you find a better paradigm that fits your unique use case. And a Lookaside cache basically works like this. So on fetch, you see if the item is in the cache. If the item is in the cache and it's not yet expired, then you'll just return it. So acting like a cache here. And then if it's not, then you'll just go get the new item, calling whatever function, doing whatever network or database accesses you need to do to create this new item. And then you save it in the cache and then you return it, thus allowing future fetches to, hit the cache up here as long as it's not expired and reduce your downstream load. And so, the logic is very simple, but this is quite effective at reducing load on downstream systems, which is why it's so common, and people often like to reach for it as a first caching solution. Okay, so building a Lookaside cache with F#. So we'll start by modeling the data that will live in our cache. For us, this is just a generic type wrapped in a cached item, containing an expiration time so we know if it's still valid or not. And so it looks like this. So we're calling this just a cached item. It's going to be generic, so you can pass in the value, or the type, I should say, that will be stored in the cache. This is very useful so that F# can understand what is being cached, and so we can rely on the type system both when we're adding items and pulling them out to try and make invalid states unrepresentable. And we store this value here as a prime t. And then we also provide an expiration, so we have a date time offset. And this will give us a, uniform data model that we can then operate on inside of our cache, all while allowing any kind of type to be passed in. This also gives us a nice interface if you wanted to add additional metadata about this. Like sometimes you might also want to say like the time that it was stored, or what is the actual key that's attached, and this might be useful for purges or something, some of the more advanced like caching things you might need. But for now, all we need is these things because our cache is very simple. And now that we have our cache data model, we can go ahead and build our caching logic to operate on that model. And so here I've got a description, of what this cache does, and all the code is here in this blog post, but we'll switch over to my editor so we can get a little bit of syntax highlighting and walk through what it does. Okay, so here we are in my editor, and I'm in my HAMY Labs code examples repo, which is linked in the blog post. And here we can see that we have the cache implementation. So here's that type that we just looked at. And here we have our cache, which I'm just calling a simple key cache. And so we can see that here it's a class. It takes in prime v, and this is how we are allowing you to pass in the type of the generic so that we get a type safe cache on whatever type you're trying to store. On creation, we are creating a concurrent dictionary. This is, in this .NET standard library and allows for a little bit of concurrency control on writes. We don't actually use this that much in this cache. It's a very simple cache, but it is here if you, wanted to go further on that front. And we can see that really it's a string. We're just making sure keys are very simple. String keys, and then here it's going to have a cached item of prime v, and again, so that's how we're passing in the type here. And then the only thing we're exposing in this cache is this function get or add async, and basically what it's going to do is, the Lookaside logic is going to try to get the item if it's in the cache, and if it's not in the cache, then it's going to go refresh the thing, save it off, and then return it. And so we need a few things from the caller. First is the key that we're going to look up. Next is what function do we call if the item is not there? How do we refresh this? How do we get the new value out? And this is going to be of type string, so it passes in the key and then task of prime v. One of the reasons that we're passing this in every time is to give the caller a bit more flexibility. If you wanted to change out the refresh function, we allow this. Oftentimes for most caches you won't, but there are some interesting cases where you might want to do this, and so this just gives us flexibility later on. So that this is more composable, more flexible. And then we pass in the TTL, the time span, to know like, okay, once we get the new item, how long should this thing last anyway? And we wrap all of this in a task. This is one of the downfalls, I think, of concurrent dictionary as it stands in the .NET standard library, is it does not have a task awaitable for updates, which, if you need to create a new item that requires IO, could be a little bit of a thread hog. And so this wrapper, basically all it's doing is allowing you to have an awaitable around this. So now we're in a task. We're going to save off now so that we have a static time to compare against. And then we're going to look in our cache with try get value to key, and then we're going to match this. So if it's true, that means we did find the value in there, and then we'll pass in item here and just check, if the expiration is greater than now, so the time it expires is in the future, then we know like, hey, this thing is still valid. It's not expired yet. And so we can just go ahead and return it. Otherwise, we're down here, which means that, either we did not find the value or the value was found, but its expiration is too far. It's stale. So we need to go get the new one. So here we do our refresh function with the key, awaiting this so that we can get the new item. Then we're going to create our cached item, creating a new expiration at now plus TTL, and then we're going to add that to our cache. Now, if you wanted to have this be a little bit more robust for concurrency, then Concurrent Dictionary has other operations that you could do on this, but for my purposes, I really just care about getting caching in like the 90% case, and then allowing the refresh to happen with the task. And so I don't really care about using Concurrent Dictionary that much here. After we save this off, we then just return the new result, and that's how we kind of build the entire logic of the Lookaside cache. Okay, so that's the cache, but as always, I am just a random guy on the internet. You should never trust me. And so I want to demo this to you of how we're actually using this F# Lookaside cache to prove that it's actually working the way I say it does. And so in this demo, basically what we're doing is on the initial fetch, we're going to show that it refreshes. And then if we fetch again, then we're going to show that it doesn't refresh because it has a cache hit and it's in the, expiration window. It's still valid. But then if we wait till after the TTL expires and then fetch it again, we do see that it refreshes, thus to show that, the cache actually saves our downstream systems as long as the item's valid. Otherwise, it actually goes and gets the new one. Now, the full source code for this example code can be found below, including all the cache implementation and stuff, but Haminians members do get access to the full source code files here on GitHub, as long as, or I guess here's like, you can see it on GitHub, but you can also see that I've got dozens of other example projects if you want to look at those as well. So if you just want to like clone this and run it on your own machine, join this and you get access to all of these. Okay, so back to the examples. Basically what we're doing is we're just setting up a simple refresh function that is going to do a few things. So, in your system, this would probably be accessing the database or calling an API or something. For us, we don't really have any data. So all we're going to do is count the number of times that we've refreshed and then print this out so we can see like, oh, this refresh function was called. We're going to start the refresh count at 0. So on the first refresh, it'll go up to 1. And then it's just going to print it out so we can easily see it on the CLI. And then it will return that because this is the new value, if you will, for that item. And then we will actually create the cache like this. We just create the simple key cache and then we pass in the type it is, which is just an int. It's just storing, a string to an int. Then we're going to do a cache TTL, which here is just 2 seconds. And then we're just going to use the same cache key throughout so we can actually see that it's being cached or refreshed. So we just set it to, a string value. We're creating a little helper for getter add, which basically is just saying, calling the getter add async, it passes in the cache key, the refresh function, the cache TTL, and then it just gets the result of the task. That's like calling it synchronously. In prod code, you probably wouldn't do this, but for this test case, it makes it much easier. And so here we can see the test cases. Basically, we expect to refresh the time we call it first, and then we expect to cache it because we should be, hitting this way sooner than the 2-second expiry. Then we're going to wait for the entire TTL, so theoretically that item should be expired, and then we'll call it again and expect a refresh. So let's do .NET run here, and it prints to the console. So we see it starts up, we expect a refresh, and so we do see refresh count is 1 and the value is 1. And then when we call it again, we actually expect to cache it, and so we see that the value is still 1, and we also do not see a refresh log, so we can see that it actually did hit the cache. And then we wait till the expiry time, which is those 2 seconds, and then we fetch again, and we expect a refresh, and we do see that, we get this refresh log, and the value is now 2, so it did update correctly. So that's the simple, test case proving that this works. Next. So this is a very simple cache implementation and is missing many of the features and functions and perf optimizations and concurrency safeguards that a more robust implementation would have. So use this at your own discretion. If you're looking for an off-the-shelf cache that's like production approved, you might consider using .NET Standard in-memory cache to start. It's basically a wraparound concurrent dictionary like I've done here, but with a much more robust and complete implementation, aka thousands of engineer hours from Microsoft have gone into making sure this thing actually works and doesn't have edge cases, whereas mine I literally threw together in maybe an hour. So if you're going to prod and like your job depends on this, probably use that one. That said, sometimes you just want a simple implementation of something without taking external dependencies. So in those cases, this cache should work fine. In fact, this is the cache that's currently being used for 1 million checkboxes, and it seems to work fine for all of my users. So for those use cases, it should be okay. Now, if you like this post, you might also like creating a bot for my site using actors in F#. You might also be interested in build a full stack web app with F# and Falco. And finally, how I built a stock option scanner in F#. So that's it for this video. Thanks for watching, and I'll see you in the next one.